Welcome to Math TV with Professor V. It is Saturday, July 15th, 2023. Here's your integral of the day. We have an indefinite integral of e to the 2x over e to the 2x plus 3e to the x plus 2 dx. So if you want to try it on your own, I'll give you a little baby hint, just a baby hint. It's from the section on partial fraction decomposition, but don't jump to that just yet. Okay. That's all I'll say. Now, in case you need a little reminder, when you have e to the 2x, that's the same as e to the x quantity squared, right? Remember, when you raise a power to another power, you multiply these exponents. And so when I notice the denominator has a e to the 2x and then an e to the x, that's reminding me of a quadratic polynomial. It's not a polynomial, but it will be if I make a u substitution. So that's what I'm going to go ahead and do. I'm going to let u be e to the x. And then du would be e to the x dx. And watch how everything's going to come together so lovely. So in the numerator, I have that e to the 2x. For a hot second, I'm going to rewrite it as e to the x times e to the x. And then I'll put that dx up there, right? If you have e to the 2x, that's the same as e to the x squared, which means I have 2 e to the x's. And then in the denominator, I'm going to write it just a wee bit differently. I'm going to write it as e to the x squared plus 3e to the x plus 2. And then hopefully now you can see how the substitution is going to work out. So du is e to the x dx. Well, I have that right here. Boom. That's beautiful. And then everybody else here highlighted in blue is just u. Let me get rid of that one. So u is e to the x. Do you see that? Right here. Okay. So now let's go ahead, rewrite the whole integral in terms of u. Don't do it bit by bit. Don't leave x's and then part of it is u's. That's very bad form, not well defined. Okay, so this e to the x right here, that's going to be a u. Then this e to the x dx, that's du. Fabulous. And then in the denominator, we have u squared plus 3u plus 2. Woo! All right, now this is where it comes into play. We have a rational function, polynomial in the top, polynomial in the bottom. The degree of the denominator is higher than the degree of the numerator, so it's time to do partial fraction decomposition. Let's abbreviate. We love a good abbreviation in math. So the denominator factors u squared plus 3u plus 2. That's going to factor into u plus 2 times u plus 1. Look at each of these factors. They're linear, right? U is just to the first power, and they're not repeated. So the partial fraction decomposition will have the form some constant, let's call it a, over u plus 2 plus another constant over the other factor from the denominator, u plus 1. If you need a recap, I have the partial fraction decomp video linked in the description. Okay. Now let's solve for a and b. First step's always the same. Multiply through by the LCD. So multiply by u plus 2, u plus 1. And then let's see, we've got u equals a times u plus 1 plus b times u plus 2. A couple different ways to solve for a and b. What I like doing for this kind of setup, I'll just let u equal -1. I chose that on purpose because I know that would make the quantity u plus 1, 0, if u is -1. So then on the left-hand side, I know that -1 equals a times 0 plus b times -1 plus 2 is just 1. See how lovely? Yes, it's so lovely. So then I know b equals -1. And then to solve for a, I'm just going to plug in -2 for u, since that will make the other factor 0. So let u equal -2. On the left-hand side, we're just going to have -2 equals a times -2 plus 1. That's -1 plus b times 0. So then I can see, all right, a equals 2. Great. So now our integral has become something very easy to integrate. we have a over u plus 2. A is 2, so 2 over u plus 2. Plus b is negative 1, so I'm just going to write minus 1 over u plus 1. Don't forget your du. All right, both of these easy peasy to integrate. They're just going to involve ln. You shouldn't have to do any extra subbing because all you have is plus a constant, so calm down. So 2 ln absolute value, u plus 2, minus ln absolute value, u plus 1, plus c. And then, oh no, we are not done. Remember, u was e to the x. Did you forget? Right here. U was e to the x. So we have to go back, replace with our original variable. So we have 2 ln. Now, I don't need to keep absolute value because e to the x is never negative. So I can just switch to parentheses. Okay. And don't do some weird garbage distribution, okay? There is no distributive property with logarithms. If you need to go back and review, there's only 4 log properties for simplification. You're not allowed to create your own. Don't even think about it. Now, this is not the final answer the way the back of the book has it. I would take it on a test, though. I mean, let's be real. This looks lovely. If you want to box it and call it a day and you're in my class, bravo. What you could do, though, if you want to combine it to a single logarithm. So first we're going to move the coefficient and make it the exponent on that argument right there. So we've got ln e to the x plus 2 squared minus ln e to the x plus 1 plus c. And then again, since we have subtraction of 2 logarithms with the same base, they're both ln, then we can combine it using division and write it as ln of e to the x plus 2 squared over e to the x plus 1 with only one ln, like it applies to all of this, plus c. I don't know. I don't think that looks so much better. Do you? I'm all about aesthetics. Like this, I don't know. It's fine. It's great. I would totally be happy if you left it like this. I'm not even joking. So I'm chastising you right now for not remembering the log properties. Allow me to remind you. If you have ln of a times b, it doesn't have to be ln. It can be any base, but we most often work with ln, and I love writing ln because I don't have to lift my pen or stylus in this case. Ln of a divided by b, that's ln of a minus ln of b. And then if you have ln of a raised to the b, and that exponent only applies to the argument, right? Then that's b times ln of a. So those are the biggest ones that you would use in this case, okay? Yeah, I know I said there were 4. There's more if you go back to the logarithm lesson. Okay, I hope you enjoyed the integral of the day. That really just does wrap it up. I could talk about stuff forever if you let me, but let me not ramble. It's Saturday. I'm going to go to ballet later. What else? The beach, maybe? I don't know. I haven't decided. I hope you all have a wonderful weekend. If you would like to check out the rest of my YouTube channel, it would make me oh so happy. Please hit that thumbs up button and subscribe if you're not subscribed already. And I have full-length video lectures on pre-calc, calc 1, 2, 3, even trig. My algebra playlist is half completed. I should probably finish that one of these days. Also, if you just want to see what I'm up to, you can follow me on Instagram and TikTok at Math TV with Professor V. And if you want access to practice exams, worksheets, all sorts of extra goodies, then you can join my Patreon. Link is in the description. Have a great one, you guys. Bye-bye.